So good morning, everyone. I'm Lucia Schiavon, a postdoc at the University of Turin. And today I'm going to present a joint work with Maria Laura Di Tommaso, Dalit Contini, who are both here in the room, and also with Daniela Piazzalunga and Caterina Muratori. I'm just going to share the screen. One moment. Okay, so today I'm going to present the results of a study on the impact of the COVID-19 pandemic and school closure on learning inequalities in mathematics in primary education in Italy. Due to the COVID-19 outbreak, all over the world, schools were closed for several months, starting from spring 2020. It was the first time since the human development concept was defined by the United Nations Development Programme that it predicted a steep reduction of it and raising a concern over pupils' achievement and learning path, both in the short term and in the long term. It's very important to assess the learning loss of pupils in primary school in order to define well-informed policy that can mitigate the impact of the pandemic. In Italy, the first Western country hit by the pandemic, schools were closed since February 24 until the end of the school year for almost 15 weeks. That is to say, the entire second semester. And this was one of the longest period of school closure across the European country. And Italy was characterized by a relative low degree technological preparedness to support distance learning. And we had a lower access of families to technologies. In that year, so in the school year 2019-2020, the INVALSI test was not performed, and neither at the beginning of the following school year. So it was not possible to measure the student losses due to school closure in spring 2020, not possible at a national level. So in this context, we wanted to estimate the impact of the COVID-19 school closure on math skills of children in primary schools. Moreover, we wanted to investigate whether these effects are different by socioeconomic background, contributing to educational inequalities. And this, for the best of our knowledge, is still the unique study empirically estimating the learning loss skills in math in Italy. And also it is one of the few studies using longitudinal data. So in the literature, recent studies have provide an assessment of learning loss due to COVID-19 related school closure for a few Anglo-Saxon and Western countries. They all report declining achievements of pupils and with larger learning loss for disadvantaged children. Of these studies, the only one that uses longitudinal data, for the best of our knowledge, it's the one of Excel for the Netherlands, and they estimated a learning loss of 0.063 standard deviation for math skills of pupils at the age of 8. And we have to keep in mind that in the Netherlands, schools were closed for just 8 weeks. While in Italy, the school closure was about 15 weeks. So for our research, the ideal setting consists of difference in difference strategy, for which we need data on pupils' achievements collected at different moments for different cohorts. Ideally, this test should be anchored or equated test. As already said, the INVALSI test was not done in Italy in spring 2020, so we could not use this data. But we took advantage of data and the experience acquired by the research team in a previous project named Tackling the Gender Gap in Mathematics in Turin province. That was implemented in 25 primary schools in the province of Turin. During this project, at the end of the school year 2018-2019, it was administered a math test named the Math Gap Test to students in grade 3. So we already had data about pupils' achievement at the end of grade 3 in math for 1,044 students. This Math Gap test was designed by the research team of the GGM project in order to be also comparable with the INVALSI national standardized test, and it had been validated by an external expert. And it had a focus on numbers. So before I have a look at the graphical representation, I want to tell you that so in May 2020, we contacted the 25 primary schools of the GGM project, and thanks to the support of the Regional Board of Education of Piedmont, and we proposed them to participate to a needs assessment in early fall 2020 with classes in grade 4. So the classes that were in grade 3 when the pandemic just broke out. 14 schools out of 25 participated with 56 classes. That is a comparable number with the classes participating in the previous project. There were 50 in total. So the test was administered to these classes in October 2020 by external tutors who entered in school and administered the test and then marked it. Then we asked to INVALSI to match our data set, both the pre-COVID cohort and the COVID cohort, with their data collected in grade 2 at individual level. So to have the graphical representation of the data timing collection, so we have 2 cohorts, a pre-COVID cohort that was in grade 2 and grade 3 before the outbreak of the pandemic. And for this cohort, we had INVALSI data in grade 2, and our math gap test, so the score at the math gap test administered at the end of grade 3. And it was administered actually at the end of April 2019 and beginning of May 2019. And then we have data about the COVID cohort, which attended the grade 2 before the pandemic, and then grade 3 when the pandemic exploded, and so they were they made the experience of distance learning. And then we have also for this cohort the results at the math gap test administered at the beginning of grade 4, as soon as it was possible to enter in schools. So for our identification strategy, we rely on a difference in difference model, exploiting the longitudinal nature of our data set. We can define the model with the following equation, where Y1IKJ stands for the math gap test scores set by child I of cohort K in school J. That's equal to a sum of factors where CKJ is the dummy identifying the COVID cohort, then Y0IKJ is a vector of initial skills, which included INVALSI, math and Italian test scores, and teacher's mark about the first term in grade 2 only for math. And then we have a vector of socio-demographic variables where we control for gender, migrant status, and parents' education. Where for parents' education, we consider whether the child has at least one parent holding a tertiary degree. And then in our equation, we have a school fixed effect and the arrow term clustered at class level. Our coefficient of interest is beta 1 that measures the impact of the COVID-19 pandemic on math skills. Then, since we are interested to investigate the heterogeneous effect by initial competencies and socioeconomic condition, we add to the model interaction terms. So the main assumption underlying this model, our identification strategy, is that children of two cohorts very close would improve at the same pace during 1 year as it regards math competencies by controlling for their previous initial abilities in math. This is an assumption similar to the parallel assumption of standardized difference model, even if we cannot test it because we would need data on a previous moment in time, but we think it's very reasonable since we are talking only of 1 year of time and the cohorts are very close, it's one following the other. And then we add in the model school fixed effect to increase comparability. We administered the same test at the end of grade 3 for both cohorts. What was different for the test was the INVALSI test administered in grade 2, but we are considering a measure of initial abilities composed by all the test score in INVALSI test in Italian and math, and also the teacher's mark. So we started from a sample of 2,288 observations, from which we excluded treated girls of the pre-COVID cohort, since this is the group of children that benefit from the intervention of the previous project, and they were 253 observations. Then we had to exclude all the children with missing information related or to the MATCAP test, either to the INVALSI test or other relevant information. So we ended up with a final sample of 1,539 observations. Here we have some descriptive statistics from which we can see that here we have the mean about math test scores at INVALSI, and that is standardized at national level and also for the Italian. And then we can see that our children, the children of our sample, outperformed the Italian average, Italian average, sorry, and then we have that 62% of our sample is composed by pupils in the COVID cohort. So if you have a look at the results, here thank you. Here in the first model, we estimate a learning loss of minus 0.23 standard deviation for children in the COVID cohort when controlling only for initial abilities and school fixed effect. When adding to the model also socio-demographic controls, the estimates of the cause and impact of a COVID-19 pandemic decrease to 0.19 standard deviation and a significant 1% level. If we include in the model class level variable and not school fixed effect, still we find a significant results that's very similar to the one obtained in the previous model. However, children were not affected in the same way by the pandemic. If we add in the model the interaction term, first if we consider the interaction term between a COVID cohort and initial abilities in math, we see that high-performing children experience a larger loss. And while if we consider class level variable, we observe that learning inequalities increases according socioeconomic background of children. Here we have the interaction term between COVID cohort and the percentage of children with high educated parents in the class. We can see these results also graphically. This means that when children are in classes in schools with a lower percentage of children with high educated parents, the learning loss is higher. This may means that teachers in more advantaged schools will had found a more favorable environment to support distance learning. And it may also be the consequence of peer effect, or that depending on the perceived quality of schools, there is different commitment also of the teacher. So if we go further with the analysis, we see that when dividing the sample between children with high educated parents and children with low educated parents, we see that the previous results were high performing children were the one who suffered the most. It's true only, sorry, it is true only for the subsample of low educated parents, children with low educated parents. That means that if we compare the two subsample, we can observe that high achieving children from disadvantage. Sorry, I had a problem with going with the presentation, but so children coming from more disadvantaged background would experience a larger loss in learning, and these children are the one that benefit the most from school. And we may also add that school closure then has fastened the increasing inequalities among high achieving students that usually we can see in the following steps, so not in primary school, but enlarging in secondary schools. While for high educated parents, we don't see a larger loss in math skills for high performing children. So going back to the results, another interesting finding is that we find that females in the subsample of low educated parents are the one experience a larger loss. This may be due to the fact that families are aware that boys usually spend less time in doing homework, and so they try to compensate by providing additional help in doing the homework. Or it may be the case that gender stereotypes are strengthened due to the school closure. And this is a quite alarming result, since we know that in older times, girls performed worse than boys on average in math. So to just very quick, we have a robustness check. We replicate all the estimation by excluding also the boys that were treated in the previous intervention, and results are very similar. We have some limitation, but just trying to very short. The period between the INVALSI test and markup test, it's a little bit longer for the COVID cohort, so they may have performed better for this reason, but at the same time there was also the summer, so we have to take into account also the summer loss, and this true effect may compensate. And then since we have seen also in the descriptive statistics that our sample is made by children who outperforming the Italian average children, we may also have a limited external validity also for the characteristic related to the province of Turin. However, it is, to the best of our knowledge, it's the only study which empirically analyzes the learning loss in Italy for this period, related to the spring of 2020. It's one of the few with using longitudinal data. So the learning loss was very large and present for all the children, and but we saw also learning inequalities that have larger, especially for children going in school more disadvantaged school in terms of parents educated a lower percentage of parents with a tertiary degree, and then we saw negative effects also for high performing children from low educated parents, and especially for girls. Thank you for your attention.
Thank you so much, Lucia. This was a very interesting presentation. I'm sure we will have a lot of questions from the audience. Given that we experienced some issues with the questions online, I would like to invite the participants online to write their questions in the chat, and Lucia will have a look at that if something comes up. And in the meantime, I would like to invite the on-site audience to address any questions, please.
Thank you for the very interesting presentation. I had a question on the results you talked about lower socioeconomic status girls. And if you checked for the size of the family and the origin of the parents, because one could suppose that young girls had to care for the younger siblings who were out of school, or that the parents who could afford only one computer or one tablet or whatever, or one room where they could study, decided to prioritize the male son over the female.
Thank you for your question. That's a very interesting point. Actually, we do not have the information about the family size and about the origin of the parents. We don't have that data, but we have the information on the migratory status of the child, and we control for it. So whether it is native or not. And in our sample, we have the majority of pupils are native. But thank you, because it was a very interesting point about family size.
When I saw students who had clearly foreign last name, and they were asking me if they could take the exam from the small balcony, I mean from a 2 square meter balcony, and they could see the rest of the family inside with the younger kids. And so I was wondering if that's just something I saw a couple of times, of that's quite common.
Yes, and that's thank you for sharing also your experience and you know, the information about low socioeconomic status coming from the education of parents, and then all the information that were available from INVALSI dataset, we exploited them. So we added the origin of the pupil, and then the education of parents, and that was a limitation of our data. But we would definitely like to add also this other control as you suggested.
Thank you. I think we have a question in the chat. If you can maybe read it out loud, Lucia. I don't have access to it.
Thank you. Thank you for the presentation. I would like to know if you have data on reading ability as well as math, since some of the results you observe could differ. Together with the colleagues from UCL, we are working on a similar project, but on older pupils in INVALSI, and we find that results differ significantly between math and reading scores. And this was a message from Alessandro Ferrara. Okay, so thank you, Alessandro. We have information, data on reading ability. Actually, what we have is the results at the Italian test of INVALSI in grade 2, and we use this information within the vector of initial abilities. So we control for it like previous abilities of the child, while we cannot run the same analysis on reading abilities in grade 3, since our test was only on math skills. But I think it would be very interesting to know a little bit more of your research, since they are also very connected. If and we are going to write to you to then be in contact. Thank you.
Thank you. Any other questions from the audience on site or online? In the meantime, if not, I will have a question. You have very important results that are showing huge inequalities. And I was just wondering, what can we do with these findings? What kind of support could we suggest for schools, for parents to deal with this situation? So if you can share that with us, that would be great. Thank you.
Thank you. And actually, as the research team, and here with Maria Laura Di Tommaso and Dalit Contini, and with other experts in math teaching, they're working in other projects, trying to find some way also to give their activities for teachers, and then to offer the other activity to be implemented in the schools where they may help in mitigate the learning loss. I don't know if maybe you want to add something more. If since Maria Laura is here,
please go ahead. Thank you.
Thank you.
Thanks for your question, Maria Magdalena. Yeah, we as Lucia mentioned, we are developing a second sort of third maybe project where we would like to extend the previous project where we use some mathematics laboratories together with primary school children to try to see if implementing this type of more participatory math teaching methodology could help to close the gap that has had an origin during this COVID-19 outbreak. But in general, yeah, we did what has been very clear in the literature, also in the UK, is that when you try to teach children in small groups, or if you have enough resources in one-to-one, but also trying to have small tutorials in small groups, that is the most efficient way to try to fill the gap. Thanks.
Thank you. If there are no other questions, now is the last opportunity. Nothing in the chat, Lucia? Nothing.
No, I just wanted, if I can, to share again the email address, if someone maybe in the chat want then to get in touch with us.
Perfect, please.
So, because I just closed then the presentation without leaving it. This is my email address, and here you can find also the address of the project. And so thank you all for your attention and your questions.
Thank you all for being here for this session.